Hello everybody and welcome to another lecture of data analytics, still covering the basics of Python programming language. So last time we were talking about code that repeats itself, and it can repeat itself an infinite amount of times or a defined amount of times. Now that is a little bit more interesting, and there's two main ways that you can define when code should stop repeating itself. The first one is, of course, by using a condition that is reached based on your specifications, and that's the while loop that we talked about. And there is, of course, the other type of loop that we're going to talk about today, known as the for loop, which is used for a counter-based iteration system. So when you have code that you would like to run a specific amount of times, the best way to do that is actually with a for loop. Whereas a while loop, again, is meant more for a code that is going to stop depending on a condition that, of course, is going to vary. So you don't know when that condition will happen. It can happen on the 5th iteration of the loop. It can happen on the 100th iteration of the loop, or it's possible that it could not happen for a long time. But ideally, you want that condition at some point to actually come up, because otherwise you just have an infinite loop, which means it's going to run forever, which I would argue that you probably don't want unless you have intentions of making your code run forever, which I suppose you could have an argument. Like, suppose you make a machine that you just want to have on forever until it just stops working. Then I suppose, yeah, that would be a legitimate usage of an infinite loop, but even that one may have a condition like an off button so that it actually shuts down elegantly instead of you just cutting the power mid-loop. So even that probably has some kind of condition to stop it. So yeah, okay. So we also talked a lot about last time about the usage of lists in Python and how you can store a heterogeneous type of data in a list, right? Unlike other languages that require a homogeneous type of data. So what I'm saying is a list in Python can store any kind of information, whether it's a mixture of numbers, words, numbers with decimals like floats, or even characters, or other lists actually you can store. So you could actually store a list inside of a list. You want to make what's known as a two-dimensional list. You would basically be storing lists inside of lists, and you could think of as your outer list as being your rows, and then your inner list being as your columns, or vice versa. So ultimately, lists allow you to keep a assorted amount of data so that you can process it very quickly using something like a loop. And it turns out that a for loop is far nicer when working with a list, because you're going to learn about a function today known as the range function, or a range-based for loop, which will allow you to iterate through parts of your list or the entire list. And so, really cool stuff. So to start off, let us just kind of create a tiny list so that we can kind of play with that and use a for loop. And so let's just make a list, and let's just call that list data. So we have data, and if we just want to make an empty list, we can use the assignment operator and our square brackets. We could also throw in stuff into our list initially, but in fact, let's throw some things in already, since we kind of covered the basic of a list last time. So let's just put a bunch of numbers this time. We could, of course, put other things in there. In fact, let's put, for one thing, something that's not a number, and maybe we can make a program that will find what is not a number and print it out. Or maybe just print out the numbers only and not the other things. Okay, so let's do 8, 5 again, and then green, and maybe like a 2. Yeah, okay, that's good enough. So we're not so squished. Okay, so this list contains a finite amount of data. In this case, remember that when we are looking at indexing of a list in Python and a couple of other programming languages, you don't start counting from 1. You start counting the indices from 0. The example I gave you was the European style of floors. The first floor in Europe is actually the second floor in America. So like the lobby or the bottom floor, we consider floor 1. In some places in the world, like in some places in Europe, they consider floor 1 to actually be the second floor, not the bottom floor. That will be actually kind of like how arrays work. We have the first item being 0, and then the second item being actually index 1. Okay? So, having said that, if we would like to iterate through this, we have shown you how to use that with a for loop by just saying while this and then blah, blah, blah. But to do this with a for loop is so easy. If you just want to loop through every single item in this list once, look how beautiful this is. You're going to write the word for, hence the name for loop. And then let me just write an example and then I'll explain it. But I'm going to say for I in data and call. Okay? And now for now, I'm going to put nothing in my loop. So I'm going to root the pass statement. Remember that? That's just kind of like an empty statement. Just for now. We're going to fill it in with stuff, but just for now. This here is your basic for loop. There's two major components that you need to understand. This I here, and of course the usage of the word data here. So a for loop is going to iterate to every element of the list that you pass it. In this case, we are passing it the data list. Okay? So data is a list. And that list contains what we want to iterate through. Okay? So in the for loop, the last sort of variable here is going to be what you want to iterate through. Okay? The I over here, which in this case I picked I because it sounds like the word I from item. What it's going to do is that every time this iterates, it's going to take one element of the list in order from beginning to end, and is going to copy it into this I variable. So for example, when you run the data variable, when you run the data list in here, the first time I is going to contain the value of 2. The next time is going to contain the value of 4, and then value of 5, and then red, and then 8, 5, green, and finally 2. And when it finishes that one, then the for loop will terminate and it'll run through whatever code is afterwards. So whatever code is here afterwards, okay? Of course, this isn't very exciting for loop because nothing happens, but let's just say that we wanted to print out the content of the array or list. Well, you can call the print function here instead and say print I. And now it's going to print one item at a time. Now, of course, if all you want to do is print out a list because you're just curious to see what it contains, you're also able to just call print and then pass the list name, like that, the identifier. However, if you print out the list like this, you'll see that it printed out with square brackets, and it'll pretty much look identical to how I have it here, up here, in the assignment. So it'll probably look something around like this. This will be exactly what it looks like, okay? Whereas the way I'm printing it in the loop, it's probably going to print it out into multiple lines like this. So it's going to get rid of the square brackets and the commas, and it's just going to print it out like that. And then the 5, and the red. Let me make some space here so I can fit it. But yeah, we're gonna get the red in there like that. The 8, the other 5, the green, and finally the 2. So no commas are gonna be printed or anything else. Although because of the way the print works, it's going to print them out one per line. You can change that. There's ways, there's parameters in the print function arguments that you can change to change the effect between each print call to remove the line feed if you want it. So you could actually mimic the way you print at the bottom, but by default it'll do this, which is fine. The point is that you were able to work with each item. So like, for example, suppose you were trying to take the average of all of the numbers. You could do that sort of computation inside the for loop by adding them all together, and the for loop dividing it by the total. Now, of course, not all of these are numbers, but you can use a function that can check whether it's a number, so you can only extract the data that you care about. And that's very important for the data analytics world. Remember, half the work when it comes to data analytics is cleaning up your data so that you can actually use it. You can actually feed it to these algorithms that you create or the libraries that you're using. Feeding it requires it to be usually in a special format. And that format is going to depend on the algorithm's requirements. Converting the data to that is not something trivial. A lot of the times, data is in non-standard format, or it's just a mess. So an example of that could be here. Suppose that we are trying to take the average of all the numbers and ignore the non-numerical values. That's a very classical example of something that you would have to iterate through and then remove, delete, or skip or ignore stuff that you don't care about and work with it. So as simple and trivial as it seems, this is something that you would probably end up doing someday if you're interested in this stuff. So yeah, hopefully that gives you a little motivation as to why. But yeah, so this variable I that we made can be anything. You can choose any valid identifier name there. So remember, refresher, valid identifiers are upper and lowercase alpha characters, so A through Z, upper and lowercase. However, you cannot have a numerical digit, so like 0 to 9, as the first character of your identifier name, but you can have it as a second or third. So like I can name a variable D1, D2, no problem there. I just can't name a variable 1D. That will cause an error. You can also use the underscore as part of your names anywhere, but I wouldn't recommend putting it in the beginning because that's saved from special cases. So you could say something like data underscore 1. That's a perfectly fine variable name. So yeah, just a refresher on that. But yeah, so the classical variable for a for loop is an I. That's why I put it there. It also can be useful for items, but you can choose anything that you want in there. Okay, and then the data again is the actual variable name of the list that you're trying to process. So this is that's it. That's all there's to it for the for loop. This will guarantee that it runs for every item. So how about we go and try and code this for this system of just trying to pick letters, okay? So let us jump into this computer. And you will notice I put something here to clear the screen every time. Just ignore it. We'll talk about import some other time and clear screen because this will only work for Linux. So, yeah. But yeah, so let's make our list with the same components. So we're gonna call data, we're gonna say 2, 4, 5, red, 8, 5, green, and 2. Notice that the spacing is not really important. You can not space things or space them. Python does not care about that kind of spacing because it's in the square brackets. So nothing to worry about. Okay, so let's just for now do the printing. So just to compare it to you, I'm gonna go ahead and show you what it looks like to just call print data. And then I'm going to show you what it looks like when I do the for I in data. Don't forget the colon. That's kind of like the while loop and the if statement. And don't forget that you have to tab this or add some sort of spacing so that the computer understands that this is part of the for loop. And then you want to line up the line beneath it. So here, let's actually bring the printing down. You want to line up the line beneath it to the beginning of the for loop so that it knows when the for loop ends. Okay, so this is not part of the for loop. Line 7 is not part of the for loop. But line 6 is part of the for loop because of this spacing. Okay, that's very important. Okay, so as you can see, we get the hello world from this, but then we get all the numbers, all the words, no parentheses, nothing. And then at the end, we get everything together from this print data, which you can see does have the brackets and does have the little single quotes. Okay, so that's what we've done so far. It's the same thing you saw there, no surprise there. But what if we only wanted to print out the numbers, right? Well, we could put an if statement. An if statement that says, well, let's just write it first and then convert it to code. So if I is a number or a digit, then we want to print it. Otherwise, don't print it, right? So that's kind of what we want to do. And this is a good approach to do when you're coming up with an algorithm or a plan, is you can just write documentation like comments in your code. Sorry, I'm thinking, I just came out of a C++ lecture, so because I normally record this on Tuesday, Thursday, but today I'm recording it right after my C++ class on Wednesday. So I still got it in my head. So yeah, but anyways, right now, we gotta put a pass statement so that the for loop doesn't complain, because you have to have something in the for loop. But yeah, you could write something like this, and this isn't particularly any language, but it's your sort of way of starting to write your game plan. Like, you write, if I is a digit, go ahead and print this, otherwise don't print it. So now that you have some sort of a game plan, you can be like, well, I don't really need to not do anything for not printing it, so I don't really need that. Cool. All I really need to do is figure out how to check whether I is a digit or not. Well, for that, you could go hardcore, and you could like look at the value of the data type using the type function or other things. But there's no need, because there is a wonderful function in Python that this is the kind of things that takes time to pick them up. But you can check whether something is a digit or not. If it's, well, here, first of all, we have to define what kind of data we're looking for, right? Because what if we had an item here that was like this? Would we want to consider that to be a digit or not, right? So in this case, this is actually a character, but do we want to consider that a number too? And maybe we do. Maybe we want to consider that situation too, okay? So if that's the case, then you have to have a way of figuring out whether something is a digit, whether that's a numerical value, or if it's a string that represents a digit so that you can then convert it to a string, right? Because we might want to do convert it to an integer so that we can do some math afterwards, okay? So we have those two situations. So let's first do the easy one, which is like to figure out whether something is an integer or not. So in Python, there's of course a lot of ways that you can do this kind of thing. But as I was saying, there's a function that allows you to return the type of a variable, okay? And so that's useful to figure out what something is, but not very useful when comparing it with some other type, okay? So if you do something like this, let's just go ahead and run this code like this. Let's just see what, and then maybe put this on a print function. Let's see what happens. Okay, we get class type. Oh, I said int here. Apologies, I meant to say I, not int. Right, there we go. Okay, so we can see that we had a different type. So the 2 is an integer. Here, let's actually print both the type and then actually the value side by side, so you can see it easier. There we go. So we have the 2 is an integer, the 4 is an integer, the 5 is an integer, where it's a string, integer, integer, string, integer, and then .4 is a string, right? That's the one that's going to be tricky. So this type is great for seeing the type of a variable, but it's not particularly useful for comparing, for saying, okay, cool, but what I want is to know whether something is an int or not to know what it is, but whether it's something I want to compare. For that, there's a great function that is known as isInstance, okay? This function takes 2 parameters. I know we haven't coded like functions yet, but you've used them. you know, like the casting function that I said to convert something to an integer, etc., etc. So, you know, or the print function to be able to print to the screen. So you use these functions, but you haven't actually built them. But that's okay. You can still use them. So this instance function takes two things. The first thing it's going to take is what you're checking. So in this case, it's going to be your I, which is going to be the item of the list we're looking at. The second parameter right there is going to be the type that you're trying to compare it against. So in this case, I want to compare it against an integer. So I'm going to put the word int in there. And what this is going to return is a Boolean expression that represents whether the first type, so whether what this type returns is equal to this type. In other words, if this variable I happens to be an integer, then this will return true because I'm comparing an integer and an integer. But for other cases, it should return false. So let's try it out. So as you can see here, we have integer 2, and it returns the word true. That's because we're comparing this type of integer with an integer type. So integer and integer are equal. However, let's look at the string one. The string one is a string. So we're comparing string and integer, they're not equal, so returns false. Same thing with the green one. Everything else is true with the exception of the last one because the 4 is actually a string, and so it returns false. So that's good because now this Boolean expression, which will return true if things match and false if they don't. Of course, we compare this against a string and the entire logic would flip, right? So if I do string there, everything's going to be false with the exception of the red and green. So, you know, but what we care about is whether something is a number, and the other ones we ignore. Unless, of course, what we're looking for is actually the non-numbers. So, in this case, this Boolean expression can be used in an if statement to decide whether that's something that we want to keep or not. So, now that we know what this instance does, we can write an if statement that says, if this is an instance of an integer, that's something good. That's what we want to keep, right? You can write a comment that says, yes, we want to keep this for sure. So if that's the case, then here we can go ahead and say print I. Okay, and we don't need this anymore, so I'm going to comment that out. We can say print I. So this is going to guarantee that we're only going to print out the numbers. However, there's going to be one issue with this. We can see that we printed out indeed all the numbers, the 2, 4, 5, the 8, the 5, and the 2, but we're still missing the 4, because again, the 4 is not an integer. It's a string that represents an integer, but the computer doesn't know that. So this solves most of the issues, but we still have the issue whether something that is not a string, or sorry, something that is not an integer might be a string that represents an integer, in which case maybe we want to keep that too. Again, if you don't want to keep it, then you're done at this point. But we do want to keep it. So we have to do more checks. So we're going to have an else statement. However, instead of just an else statement, we could put an else if statement. So we're going to go ahead and do that. So the other scenario we want to check is whether something is a string. Or perhaps, actually, you know, let's add one more case in here. Let's say that we also have a float, you know, like a 2.5. If we have a 2.5 like this, let's go ahead and run it with the integer. I know the problem keeps getting bigger because this is really what happens, right? When you're doing these data analytics things, you try to plan ahead and you're like, well, you know, I'm gonna have issues where like things are gonna be as a string and they're gonna be integers. But then like, you're like, oh, but wait, what if something is a decimal point? Then you gotta go back and add that in, because guess what? Our whole system wasn't even contemplating that. So that's another thing we're gonna have to worry about. And then there's maybe things we're not even thinking about. So as you can see, even something so trivial as this can start to get a little tricky because you have to plan ahead all the possibilities that you're going to see when you're trying to clean up data. But this one's actually pretty straightforward. You can do another check that says else if this is an instance of a float, then we also want to keep it. Unless, of course, again, you don't want to keep it. So in this case, we can do that, and now you will see that we have the 2.5. Okay, so we took care of floats and we took care of integers. We still got to take care of ints. So let's add another else if that checks whether it is an instance of a string. And of course, if we say print here, that's going to defeat the purpose because now we're going to get red and green, right? But let's just check so we can see red and green. So we do need to check this to see if it's a string before we go further, but now we need to add another check here. You need to say and both it's a string and a digit. So how can we check whether something is a digit or not? There's a function in Python that is called isDigit, I believe. Had it saved here. Here we go. Yeah. So the Python function, you just actually call it on the string itself. So in this case, I is a string, so we play I dot, and we can say, as you can see, when you write a string variable name and you put a dot, you have a lot of different things you can do. There's a function that will capitalize your strings. That's pretty cool. You can obviously get the size of it and other things, but in our case, we care about isDigit, which is returns true if the string is a digit. And read carefully though. This says a string is a digit string if all characters in the string are digits, and there is at least one character in the string. So if a string has both digits and characters, this will return false. We can test that by just making that an option, right? So let's say we have a purple 54, okay? So now let's go ahead and call isDigit. And because it's a function, we need our parentheses. And then this one, we're gonna print it, but we're also, I wanna make sure I differentiate it from the other ones. So I'm gonna say string, just so I can see it better on the print, okay? Something like that. Okay, so as you can see, we only get that once, and that's for the ideal one, which is the 4. So this actually works without printing the purple 54 or printing red and green. Okay, so now that we know that works, we can go back and just leave it as this. Oops. And now if we run this, you can see that we get all the numbers we cared about. In fact, let's just make this a different number so it's easier to differentiate. So let's make that a 7. So you can see the 7 is right there. We can see that we have the floating point value and everything, except for the 54, right? But we didn't want that. If we did, it gets a little trickier because now we have to look at each item of the purple array or the purple word, which we will treat as an array, actually. That's what I was thinking of. But let's stop there for a minute just to make sure that we are all on the same page, that this is what we wanted to do. Although I think I said that I wanted to make an average of everything, right? So let's go ahead and do that. So let's make a variable that's going to keep track of how many integers we have. So we're going to call it count, and we're going to start it at 0. And every time that it goes into one of these, we do want to increase the count by 1, right? So, we can say count plus equal 1, and then just do that in all 3 cases. Like that. And if we run it all, also, we want to add the numbers together so that we can do the average. So let's just call it the add or the sum. Start it at 0. And so here we can say sum plus equals the I value. So that so just in case we are on the same page, what that means is sum plus I. So that is the same thing as writing sum plus equals I. It's saying take the current value of sum and add some whatever you want to it, in this case I. Okay, so these two lines, lines 12 and line 16, are identical, but people prefer to write line 16 because it's less writing. And less writing means you can do more code in less time, right? Or better code, at least. Okay, so if we do that, we have 2 variables now. We have the count and the sum. So if we would like to take the average of that, we can just go ahead and write the following functions. Well, let's write actually the print statement that says average, and then actually put it in there. So that is going to be, actually I'm going to do it outside. So I'm going to make a variable called average, and I'm going to say the sum divided by the count, right? So everything together divided, yeah. And just print it out here. However, the reason why I want to put it outside is because suppose that we have a scenario where the list has no numbers in it. What's going to happen there? We're going to have a division by 0, which will not end well. I can test that very quickly, but let's just leave it like this for now. Okay, so, yes, very good. So we have an error. We have an error in the case of I, because even though I is a digit and it's the number that we want, we still haven't converted I to an integer. So when we're trying to add it, that 7, or with the other values, it's trying to add a string. So for this to work out how we want it, we need to actually cast this to be an integer, right? Convert that string into an integer. Now that we know that it's actually a digit and it's going to convert okay, we need to convert it. So if we do that, now we actually get a good average. Okay, in fact, here, let me print out also the sum so you can see both. So the sum is going to be the sum. Let's print out the count too while we're at it, might as well. And then the average. So if we run this, we can see that the sum is equal to, actually, I guess I don't need the space. It's putting the space for me. Sorry, I wanted to make it look neat. So the sum is 35.5. Cool. The count is 8. Cool. Well, let's see if that's right. Well, it should be, because I mean everything else is right. But here, 2, 4, 6, 8. Yep. And the average is 4.4. That seems about right based on the numbers that we have here. And then, yeah, it's all good. However, here, let's get rid of this print data. Or actually, we can leave it there. That's fine. However, let me show you the example where bad things happen. So let's just go ahead and comment out data and replace it by a string that contains no numbers or is simply empty. But in this case, we're just going to make it contain no numbers just to really confuse it. If I run this now, I'm going to get this error. Exception has occurred, 0 division error. And yes, it is indeed true. We are dividing by 0. So as you can see, that's a bit of a bug, I would say, in our code. A bug is something that you don't want to happen. So how can we fix that? Well, you can start out by initializing average to 0, and then only changing that if the numbers are okay to be divided. So we can add an if statement that says if count is equal to 0, or actually if count is not equal to 0, which we can just say by just saying if count, then go ahead and do the average. That way, if this is 0, then this will return false. So then this division wouldn't happen. So if we do that now, the code will still return the same thing as it is now. But if we reintroduce that scenario where data is empty or contains just non-numbers, then the code will run. But of course, the sum, count, and average will all be 0. Which, technically speaking, the average isn't really 0. Well, actually, it's not a number in general. But what I'm saying is at least the program doesn't crash. So you can handle that differently. You could also put this print statement inside of the if statement, and then add an else that says another print that says no numbers found or something if you want. That's if that makes more sense for you as well. So there you go, like that. And then if we go back to the other one, then we still get our same code. Okay. So as you can see, today's topic is for loops, but I still wanted to give you a nice beefy example of actually using them and using if statements and whatnot. And we still have this purple 54 that we could extract the numbers from that actually. So let's look at this more. So just kind of add it at the bottom of the code. Here's something that you can do that's really cool. So I'm going to extract that value into an independent variable. So I'm going to make a variable called just a word, and I'm going to go ahead and put the data/item. Okay. So here's something cool. Sure, I could go in here and figure out what index purple 54 is, which would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I mean, I could do this, and then print word and print out purple 54. So that's perfectly fine, but there's something really cool you can do in Python when you want to print out the last element of a list. So we understand that indexing works from 0 all the way to the size, but something really cool, and this is something that is in Python but not in other languages, is you can use negative indices. So if I put -1, what that actually does is it returns the last index of the list. That's pretty cool. You can see that this is the last index. And this works also if I do like -3. For the -3, it returns a 7 because it goes -1, -2, -3. So you can actually count from the end to the beginning, but in that case, the indexing actually starts from -1 because you can't use 0 because 0 is already given as the first index, right? So this is actually index -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. So technically the 2 is both index -11 and also index 0. See? -11, index 0, as you can see. So that's pretty cool. It can become very useful. So it's a nice little tip that I hope you guys don't forget. So there you go. Purple 54. Okay. So Word now contains basically this reference to this purple 54. Let's throw it in the for loop and see what happens. So I can say for I in Word, print I. Check it out. If I do that, I'm actually going to get the individual characters of the word. So when you feed a string in a for loop like this, you actually get the individual characters. That's a really, really useful feature. So for loops are not just for lists. Well, technically this is a list. That's kind of a catch. So list in Python, we think of like, this stuff. But strings themselves are lists of characters. Just a bunch of characters together that form a nice little list. So this is cool because now, if I know that I can iterate through each of these characters, well, guess what? I could create a new word that only contains the numerical characters, right? So create a new word and set it to the empty string. So whenever you want to make a string in Python, but you don't want to put anything in it, you can just put empty quotes like this, and this creates a string that's empty. So if I go in and call the type function on the new word, you will see that this returns a error because I forgot to put a W in there. And where is it? Here we go. String right there. Okay. I can also use the is instance if I wanted to and say like is instance of new word and string, which is just str. And you'll see somewhere here that it says true right there. So yeah, that's how you make a new string, which is interesting because when you think about how a list is made, you just make the empty square brackets like this to make a list, right? So it kind of gives you a hint that maybe strings are in a way just lists, right? So yeah, but anyways, let's make a new word, and now in here I want to append to this string anything that's not or in this case not really append, but concatenate to the string any character that is actually a digit. So I can say well, first of all, let's see what I is. What is the type of I? Is it still a string, or is it a character, or what is it considered? It's still a string, you'll see. So even though the whole thing's a string, these individual things are also strings. So because they're strings, that means that we can call our isDigit function. So we can say if this individual character is actually a digit, then that's something that we want to keep. So we want to add it to the new word. So take what the current new word is and just concatenate to that this character. So new word equals new word plus I. Again, when you're using plus, here maybe I shouldn't simplify this one so you can see it easier. But that's what I'm basically doing. I'm taking new word and I'm adding I to it. Whenever you're doing this plus, in this case, is not mathematics. In this case, is concatenation, which is just sticking both together, right? So we take the empty string and we stick it with the character that we're adding, which is going to be hopefully a digit. So if I do that, you will see that, well, I gotta print it out afterwards. If I, after the loop, if I go ahead and I print out new word, you will see the 54. Great. So there's one more step to do here. First of all, we don't need to print this anymore in there. It's just kind of cluttering our thing. So you can see 54 is, let's convert it to an actual integer. Okay. So let's go ahead and, you know, call it new number, and it's going to store the integer of new word. Okay, and then we can just print out new number. It's going to look the same to us when I print it. It's just going to look 54, but now this is a number that we can add in to our sum. Okay, so now the question is, great, this is awesome. How can we put this in here? Well, we could add another elsif. So let's go ahead and take this code, actually all the way to here, and we're going to put it here. So actually, in this case, I'm going to split this, because we already, you know, if I do another else if, this is literally going to look like this. It's going to be like is instance I str and not I is digit, because that's going to return false. But that seems kind of redundant, so I don't like doing that. So instead, I'm going to split this if statement and say that it only checks whether it's a string in the first sort of step, and then it's going to have an if statement inside that checks whether something is a digit, and if it is, then we're going to run the same code that we have. So this right now, as I have it, does exactly the same thing it was doing before, but now I can add an else clause to this and put my new code in there. So in this case, I'm saying that if something is a string, if I can consider the entire string a single digit, piece of cake. Just convert it to an integer and then call it a day. Otherwise, it may or may not be something that contains numbers in it. So in this case, I'm going to go ahead and take the word that I care about, so the I, and I'm going to try to sort of build this as I go. So to do that, I'm going to just, I don't need that initially. I just need to use a different variable for this because I'm already using I. So I'm going to switch this to say j instead of I, so that it doesn't get confused between the I up here from this loop with this for loop. Notice that I'm using this I, j, and k. That's just a traditional variable name. You can choose whatever you want. Okay, so I'm still going to have my new word. And now instead of iterating in word, I'm going to iterate in I, because that's the name of the variable out here. So this is going to have the purple 54, and this loop is going to iterate through each of those letters. And I'm going to check if each of those letters is a digit. And if it is, I'm going to append it to my new word. Okay? At the end of this, I'm going to convert new word into an integer. However, in the past, I knew that this purple 54 had an integer. But if I run it like this, I could run into some issues when, like, this is just emptiness. And if I try to convert emptiness into an integer, this might give me an error. Let's try and see if it gives me an error. Yeah, it gives me an error because it's trying to convert the empty string from like the red or the green that don't have numbers into an integer. So I need to add an if statement check here before I try to do that. I want to make sure that new word is not empty, because if new word is still equal to just the empty string, it means that I went through a word that was a string but didn't have any numbers in it. So I don't want to try to convert it to an integer. So I can say something like, if new word is still the empty string, then do nothing. However, if it's not equal to the empty string, then convert it to an integer, and then actually do your math and science with it. So in this case, you know, I can print it out for reference, but I also want to make sure I add it to my count. So increase the count. And then don't do the sum to the I, because the I contains both the characters and the numbers, the like letters and numbers. So just add new number to that, since that is actually the number that we want. Okay, this could be simplified into better code probably, but like I could probably get in fact, let me show you one quick simplification. The count increment here is happening in both this section and in this section. I would argue that, because actually, well, no, because this may not always run, so no, actually, I would leave it as it is. I take that back. I don't want to simplify this. So anyways, if I do that now, you can see that I count the 54, and it is being actually accounted for in the average. You can see the average went up from like 4 to 9 because 54 was such a big number in comparison to the other numbers. So more evidence yet this worked. You can see how our code grew from like pretty much twice the size just to account for that special case of having a number in here. Do notice that the way that we coded this, if I have the following, if I have like a 1, and then I have car, and then I have like a 99 afterwards, it's actually going to probably take the 1 and the 99 and combine them together. So it's actually going to make 199. You may not want that. You may actually want to keep the 1 and the 99 and actually make those into separate numbers. That's a whole different story. We would have to go in here and modify this even further to account for that situation. So probably what we would want to do is we would want to go in here and keep track of if every single value that we're considering is a digit, and if there's a break from that, then we want to split it into its own group so that we store that. So basically, as you run here, you set a boolean to true, and then if it ever goes in here and this returns false, if you already built a word here, you want to pop that out and save it, or add it to a list and then save the list at the end. So it would be interesting. So maybe I will make that into a small assignment for you guys to do, is how can I take the current code that I have, so you can take this code and I will upload a copy online, and I would like you to modify it so that it can actually handle cases like this. And maybe I'll put in a couple of more in there for that. So maybe like 2 air, fire, yeah, like that. So now, how can you split all these numbers up so that the 2 and the 4 are independent of each other, the 24 and 31 are independent of each other, and so on. So maybe I'll make that be your homework assignment, since I mentioned that I would have some kind of assignment based on looping. So you have to take this code and modify it so that you can print that out, okay? So, yep, I think that's all I'll say about that. There is one more thing that I wanted to show you, and that's the range function. So let's just make another file for this, since this is kind of getting a little bit big. Okay, so right now, we know how to basically iterate through all of these lists. But what if you just want to print out numbers, or you just want to run some code, not particularly connected to a list, but you just want to run it 10 times? Like, I want to print the word hello 10 times. How do I do that? Well, the range function would be great for you. So you can say for I in, and instead of writing a list, you can write the word range and then put a number that you want. So let's say you put a 5 in here. If I go ahead and say hello now, you will see that I get 5 hellos. So the range function is amazing because you would just give it a number, and that's the number of times that this code is going to loop through. And you could have, of course, a million lines of code in here. Don't forget that, if I write code outside of this, this is outside the loop. This is not part of the repetition. So you'll see the world print only once, but you see the hello print 5 times. So it's a great usage of the loop. Very, very nice. Also, the I variable here, what it contains, we can see that by just maybe appending that here. You can see it contains the numbers from 0 to 4. That is kind of what the number here is pulling from the range. So internally what the range function does is it actually kind of makes a little sort of list that contains just the numbers 0 to 4, and that's what it's returning. So that's what's happening internally. And it's useful because you might actually want to use that as a counter of some sort. Because it's a list that it's building, you can actually customize it to only run a specific range, hence the name, of values. So for example, suppose that I wanted to run 5 times, but not particularly from 0 to 4. Maybe I wanted to run it from like 4 to 9 or something. Well, if I want to run it from 4 to 9, then I can do something like this, but do keep something in mind. That when you do the range function like this, from 4 to 9, it's going to print out all numbers, 4, 5, 6, 7, 8, but it's not going to print out 9. It turns out that when you run this function, it starts from the first parameter is going to be your start, the second parameter is going to be your stop, and there's a third parameter called step, but I'll mention that in a minute. Of course, if you just run it with one parameter, it just means how many iterations you want to run. So basically the stop. But it doesn't include the stop in the count. So you'll see 4, 5, 6, and 7, and 8, but you will not see the 9 printed out, as you can see there. So it's running the 5 times that we want, but it's not including the 9. If you wanted to include the 9, then you'd actually have to go to 10, and this would actually run 6 times, right? 4, 5, 6, 7, 8, and 9. So that's an important thing to keep in mind. But it's very nice because, again, you might want to use these numbers for other purposes. So you may want a specific range, such as, what if I want to print out only the 4th, the 5th, and the 6th element in my list, right? So let's just take the list from over here and just kind of copy it here. And then suppose that I wanted to just print out, so for I in range, maybe from index 3 all the way to index 6, or actually 7, because I want to print out index 6 as well. So then I can say print, and then, sorry, there we go, data, and then print out that index, so I, okay? So if I do that, then I'm going to be printing out red, 8, 5, and green. So 0, 1, 2, 3. So I am printing indexes 3, 4, 5, and 6. So that's another way to access actually the list members as well, too, if you want a specific set of, subset of them. So very, very useful. It also works counting down, I believe. If you change this, if you add a third parameter here, the step. So the step, if you put a 1 here, you'll see that nothing interesting happens. It's just the same thing. But if I make this like a 2, it means it's going to go in steps of 2. So you'll see that the numbers increment in 2s, like 4, 6, and 8. You see that? So instead of going from 4, 5, 6, 7, 8, 9, it just goes 4, 6, 8. Does not do 10 because 10 is already out of the limit because 10 is not included in there. But if I go ahead and put 11 in here, then you would see the 10. And so on. But even cooler is I can put something like a -1, and then it goes down, it counts down. So here it's going, here, let's rerun it with numbers so it's easier to see. So here, this is that one on this one, because otherwise it becomes kind of tricky to see what is happening. 3 to 3, -1, so it only printed world. I thought that it would count down. Let me check. Range, step. Specifying the incrementations. Let's try a bigger range of numbers and see what happens. World. Maybe it does. It just does not like the negative numbers there. Maybe it's not meant to do negatives. I thought it would work, but you can definitely do positives. You can go in increments of 3 if you want, and go like that. 2 red, green, 2.5, and so on. So, yeah. I thought you could do the negatives. Yeah. Range Python negative step. Python range with negative strides. It should work. I think it's just having a hard time because of here. Let's just print out I. I think that'll be easier to see what's happening. Like that. Okay, so if we do -1, For I in range 0 to 10. Oh, I know what it is. I know what it is. Apologies. Since we're counting down, this is still the start and this is the stop. So because we're starting somewhere and then we're counting down, we are immediately stopping. So we're only putting one item. So we need to flip these. Since we want to start at 10 and then stop at that. So that's what's causing the issues. There we go. So now it's actually working. You see that? So our issue was that, the start and the stop still work the same. So if you're going to be counting down, you want to make sure that your start is a bigger number than your stop. So here it was just instantly stopping basically because it was like, well, we're already done. So that's what was happening. So even I sometimes, I guess, forget these things. I don't really count down with the range function, I guess. That's probably why I really ran into that. But yeah, that is basically how your range function will work in Python, and it's very useful in combination with your for loops to be able to work your way any way that you want in a loop. Although again, you can do what we did last time, which is just directly put in the data type of the list, directly put in the list variable, and then just use that as your iterator. So yeah, but all in all, that shows you the basic usages of using for loops and lists in Python. Next time we will maybe do some practice more on this and then move on to some other interesting things that I have in mind. Okay, but for your assignment, I am going to make you do that modification to the existing code base to be able to handle those cases. And I think that will be something interesting. And I look forward to seeing your different ways of doing that. It's not that hard, but it will require a little bit of critical thinking, I think, if you're not familiar with Python at least. So that's it. That's all the video that I have for today. Now you should be pretty strong with loops. So that's kind of like the last big key of the puzzle. So I think at this point now, a broad range of power of things you could do in Python opens up. So from now on, it's a lot of fun stuff. So I thank you all for watching, and until next time, take care. Thank you.